Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. A team of scientists in China has recently observed a gigantic jet of lightning above thunderclouds, nearly 90 kilometers above the ground. Scientists acknowledge they don't fully understand this type of electrical discharge in Earth's upper atmosphere, and only recently did mainstream science recognize the phenomenon actually exists. However, for decades, airline pilots have offered eyewitness accounts of spectacular lightning above thunderstorms towards space. What does this phenomenon tell us about the nature of lightning and the Earth's electrical environment?
For decades before these discharges above storms was recognized by scientists, airline pilots witnessed these things but were afraid to report them. And the first time I read about them was in the late 90s. Somebody actually had the courage to report the fact that they had witnessed these strange lightning bolts emanating above storms and climbing as high as they could tell into space, towards space. Of course, the pilots were worried that reporting such things would call their fitness to be a pilot into question. Now, one of the problems is that science is supposed to be evidence-based, but here you see a case where evidence is not admitted because it doesn't fit prior beliefs. The thing is, and this is not generally known, scientists still do not understand lightning. So if they don't understand the lightning which is visible and obvious to all, then lightning above storms, which is not so obvious and very difficult to catch on camera, was not believed for some time. And yet, surprisingly, back in the 1920s, the Scottish physicist C.T.R. Wilson predicted the existence of brief flashes of light high above large thunderstorms. So some scientists were, at that stage, recognizing the electrical connection between the ionosphere and the Earth's ground.
Above the clouds lightning demonstrates the existence of an electrical potential on Earth in relation to its external environment that mainstream science has yet to recognize.
I first wrote about the lightning above storms in January 29, 2002 on my website. And in there, I pointed out that there had been an experiment by Professor Edgar Bering, a physicist at the University of Houston in Texas, who flew a high-altitude balloon above a storm. And the thing that he found, and which was most unexpected, was that when these lightning strikes occur into the ionosphere and also below the storm, the charge was already sitting there. It was just waiting for the event, so to speak. It didn't take time to build up between lightning bolts. And this is one of the aspects of the electric universe, which then can explain this, but the standard theory, which sees lightning as some kind of a generator, which generates the clear air electric field of 100 volts per meter between the Earth and a clear sky. They thought storms generate this voltage, and also there was some kind of circuit where the lightning actually generated power. Of course, the generation of power then relied on water droplets doing things in clouds to separate charge. But none of this has been verified. In fact, it's still a mystery as to how lightning is generated by water droplets moving in a cloud. The electric universe sees the lightning and the cloud activity as being a load. It's being driven by electricity from space coming from the ionosphere to ground, or between the ground and the ionosphere. So that the lightning itself, the charge is already built up above the storm, which is what Professor Edgar Bering found. And these red sprites and blue jets and so on that you see above storms, powerful storms occasionally, are an indication that the lightning itself, the circuit, extends 80 to 100 kilometers up towards space. And beyond that, NASA has found that there is an electromagnetic connection between the sun and the Earth, which, since it's based on the magnetic field lines traveling between the sun and the Earth, these are actually indications that there is an electrical circuit connecting the sun and the Earth, and that the electrical storms on Earth are but a tiny fraction of the power that actually lights up the sun. Now, when we go to other planets like Venus, they don't have water clouds, Venus has what has been termed a kind of smog, and lightning isn't generated by smog. And yet, when Venus was first investigated by spacecraft, it was determined that there were superbolts on Venus. Now, in that case, Venus cannot discharge through clouds. It has to go from the ionosphere straight to ground, so it's to be expected that that's what you would find. On Mars, the clouds there, they're very, very few. It's more like a kind of a mist above the ground in places. The atmospheric pressure is very low, so instead of getting lightning on Mars, you get glow discharges, which drive what are called dust devils. Only these dust devils can be as high as Mount Everest. So in Mars' case too, the discharges have to occur from the very ionosphere of Mars to ground. On Earth, I suppose in some respects we're lucky we don't get these ionosphere to ground lightning bolts, which could be quite destructive. Instead, we have the clouds acting as a kind of circuit breaker.
For reasons of safety and efficacy, it is essential that NASA consider the Earth-Sun electrical connection in the planning of all future space missions.
There are two experiments that have been performed, and I actually warned against them back in the 1990s, early in the 1990s. One is the space tether experiment, where you fly a satellite at the end of a long wire held radially from the Earth, and you then measure the current that's generated in the wire by the fact that it breaks across the Earth's magnetic field. And I suggested at the time that this ignored the electrical connection between the Earth and the Sun, and that by trailing a wire radially, you would possibly achieve voltages which would be destructive. And that's exactly what happened. The tether separated at the shuttle, and the satellite at the end of the tether was lost. And I suggested if they try to do it again, the same thing will happen. But then even more adventurous was the idea of building a space elevator, which would allow you to travel up and down an elevator cable, if you like to put it that way, between the Earth and space. But of course, that would just act like a giant lightning rod, so that it's an impossible dream. And any attempt to build the space elevator is doomed to failure.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.